Today we're going to familiarize you with the EV-400 high voltage safety trainer. This unit is designed to behave like a real battery electric vehicle, but it's in a controlled classroom environment where we can safely teach high voltage measurements, isolation, interlocks, and fault diagnostics. The EV-400 operates at approximately 400 volts, but its current is limited to only 0.2 milliamps, which is what allows us to work with real high voltage while remaining safe for instructional use. Every EV-400 ships with the following core equipment: a set of Class 0 high voltage electrical gloves, which are rated up to 1000 VAC, 1500 VDC. And while it is a small amount of current, we strongly encourage instructors to require students to wear these gloves whenever they're working on the trainer. This reinforces the same high voltage safety procedures and habits used on real electric vehicles. 2 inverter cables. One cable is missing an HVIL pin, which allows us to demonstrate how an open high voltage interlock loop prevents the system from enabling high voltage, reinforcing the consequences of an incomplete or improperly connected high voltage circuit. And the Klein ET600, the primary diagnostic tool used with the EV-400, which combines a Cat3 at 1000 volt digital multimeter with an insulation resistance tester capable of generating up to 1000 volts. This allows us to teach both high voltage measurement and isolation testing, using the same meter students will encounter in the industry. If we follow the flow of high voltage through the trainer, it starts at the high voltage battery and its manual service disconnect. Then it moves through the contactors. From there, the system splits into 2 parallel paths, one feeding the inverter and AC motor, and the other supplying high voltage loads like the AC compressor, cabin heater, and DC-DC converter. This layout allows students to see exactly how energy moves through a real electric vehicle. The remaining components on the trainer include the main power switch, the fault buttons and fault indicator lights, the control board that includes the ignition, pedals, gear selector, and cabin comfort switches, and a real key fob with a Faraday cage. This allows instructors to demonstrate a real EV startup sequence into ready mode and in the entire high voltage pre-charge sequence. And lastly, the system includes a 12-volt battery, great for teaching live dead live testing, and a first responders loop. When this loop is opened, it sends a shutdown signal that commands the high voltage contactors to open, removing high voltage from the system just as a real vehicle would in the event of an emergency. The EV-400 curriculum is broken into 4 core documents: the operation manual, which explains how the trainer works; the instructor manual for teachers' eyes only with extra details, notes, and fault behaviors; the student manual with assignments and schematics, followed by the answer key, which gives answers and results to the teacher. All of these manuals are available online through Consul Lab's curriculum portal. Once logged in, you'll have access to any products your school owns, including manuals and assignments, and they'll all be available for download, printing, or even use in your online classroom. The EV-400 includes multiple built-in faults, covering HVIL issues, isolation faults, grounded components, contactor failures, and subsystem failures like in the DC-DC converter and HVAC. Faults are set using the keyed fault selector. The instructor turns the key to the unlocked position, presses the desired fault number, and then turns the key back to the locked position and removes the key. Once activated, the fault behaves exactly as it would in a real vehicle, allowing students to observe and diagnose authentic system responses and diagnostic outcomes. When a fault is active, you'll see it reflected in the fault indicator lights, allowing students to correlate symptoms with system behavior just like indicators on the dash. Once the fault condition has been corrected, faults are cleared using the ignition button. Press the ignition button by itself without pressing the brake or accelerator. This action clears the stored fault codes and turns off the fault indicator lights. The EV-400 does not use a scan tool. All fault clearing is done directly through this control interface. To operate the EV-400, plug the power supply into the trainer and then into a standard outlet. Switch the main power on. A green power indicator light should illuminate. Place the key fob into the key fob holder. This authorizes the 12-volt control system. An indicator light near the key fob confirms the system recognizes the key. Ensure all safety and system switches are in their normal operating positions. All high voltage and HVIL switches are closed. The 12-volt battery switches are closed. The AC and heat switches are in the off position, and the gear selector is in park. Hold down the brake switch and press the ignition button on the control board. The trainer will complete its startup sequence. The system must be in park before enabling drive, just like a real electric vehicle. Once placed into drive, students can press the accelerator and observe the inverter in operation and watch the motor spin. To give you a better idea of what this trainer can be used for, let's look at a few of the most impactful lessons that instructors can use. Student assignment 4, measuring high voltage. This is often the first aha moment for students as they learn how to safely verify the presence or absence of high voltage. By measuring full system voltage at components like the AC compressor, students can see firsthand that high voltage exists far from the battery itself, reinforcing why the entire high voltage system must be properly de-energized before service can begin. Student assignment 7, contactors. Students observe how contactors operate, what conditions allow them to close, and how faults prevent them from engaging. They also learn in more depth how the pre-charge sequence works, seeing the order in which contactors close and understanding how the system safely limits inrush current before high voltage is applied. Student assignment 10 is about the AC motor. This lesson takes students deeper into the three-phase AC motor operation by having them observe how the inverter generates and controls three-phase output. Students see how changes in the inverter frequency and output directly affect motor speed and direction, reinforcing the relationship between inverter control strategies and real AC motor behavior. Student assignment 11 teaches about the DC-DC converter. Students will see how high voltage is stepped down to support low voltage systems, drawing a direct parallel for technicians to the role of an alternator in a traditional gas vehicle. This helps students connect their familiar 12-volt electrical concepts to how EVs use a DC-DC converter to power accessories and maintain the low voltage battery. Section 4 is a goldmine of activities around the high voltage interlock loop, which is critical for safety. This section, students will learn all about how it functions as a complete loop, how the resistors within the loop create predictable voltage drops that allow the system to detect opens, poor connections, and faults, and it demonstrates how the vehicle knows when to safely shut down a high voltage vehicle and keep us safe. And section 5 is all about faults and isolation testing. This section ties everything together by having students diagnose isolation faults, grounding issues, and safety-related shutdowns using real measurements. Students learn to interpret fault indicators, correlate symptoms to system behavior, and confirm their conclusions with voltage and resistance testing. Thank you for taking the time to participate in this familiarization of the EV-400 high voltage safety trainer. Our goal is to ensure you feel confident using the trainer to teach real-world EV safety, diagnostics, and system behavior in a controlled classroom environment. If you have any immediate questions, please reach out to your ConsuLab account manager or visit the support tab on our website to submit a technical support ticket. We appreciate your partnership and we look forward to supporting you and your students as you bring high voltage EV training into your program.